This morning was, by the way, a lot of fun for me. It was on Tuesdays and Thursdays. I'm a professor of computer science, so this morning I was. Let's see, our effort was to build a little number in our tray that showed what the weather was. So, what's amazing? 25 lines later, we're done. It's just absolutely. We live in an incredible time where the things that we can accomplish are not unbelievable and astronomical technical feats anymore. It's really just a matter of keeping our minds clear so that we can arrange all of these pieces in a way that makes sense to your business, makes sense to you. Don't get carried away with too much complexity. And so that's where I want to be too. I mean, when we think about an application or we think about something that you've created or inherited, it is almost certainly going to be a some sort of database in the back end. Maybe you have a SQL server already on prem. Maybe you're already using SQL in the cloud. Maybe it's Postgres or Cosmos DB or MySQL, maybe even. There are lots of options out there. And to be honest, we as developers only have so many choices or so much influence and power to be able to make it so that we pick the tools we want. Hopefully, we get the best of the tools, but all of those, then we have to kind of couch those around different types of design patterns. Today, I want to talk specifically about patterns, just around the architecture overall. Not so many features, a handful of features. I know I'll have to talk about those. But really, it's just if I already have an application, if I already am building it and it's data driven, what are the handful of things I can do and introduce to it to make sure this application can be upgraded, can be modernized, and be put into a place where it can not just scale, not just perform, not just be secure. All of that is the table stakes, I hope you see. Instead, we want to make it so that the next developer behind us can come in and make a difference and actually improve something without being required to rewrite everything that we've done. That's the point, right? Not just how do we modernize, but how do we enable modernization, both for ourselves and for the next developer. Here's something that will help you in life. As developers, the number one thing is the next developer. I know that's weird to say, but the next developer down the line, that maintenance developer who's going to inherit the code, the best way to think about it is that developer is an axe murderer and he has your home address. The last thing you want to do is get him really worked up and angry. So you want to provide instead to him not just this like spaghetti mess of everything that's terrible. You want to provide a well organized and structured, thoughtful solution, right? So you don't want to have it so that the mess that you've got, you haven't made any better. You want to always be making things better because the idea is you can only improve something that is actually manageable. And the only thing that's manageable is where the refactoring with the intent of maintenance has happened and where the introduction of patterns so that you can not just modernize, but do all of these other pieces to componentize, to separate all of the concerns and be sure that everything is operating the way as best that you can. Now, remember, I understand sometimes you inherit a brown field, sometimes you inherit a black field, right? And it is absolutely untouchable. You can change 3 lines over here and 2 lines over there, but nothing else. Fine, I understand that sort of limitation, but that's actually pretty rare. Usually we have the opportunity to make things better, and often we have the opportunity not to make things worse. So as we're now introducing some other capability, we introduce it in the best way we can. Okay, let's talk about it just from the highest level. We have a database on the right. I'm going to assume this is SQL Server because, oh, by the way, my name is Jerry. I totally forgot. I live in Colorado. I've been part of Microsoft now for 15 years. Friends with Jeff here for even, I mean, just feels like an eternity. And I am currently on the SQL Server team. Started at Microsoft on the evangelism team, speaking directly to developers, reaching out and understanding their pain points and helping them solve it. So it's been a long time, and I love being on the SQL team. It has been, well, frankly, SQL has paid my mortgage for most of my career, even prior to coming to Microsoft. It's just been one of those things that because I knew it well, it really helped me in my career. If you look at a room full of developers and you raise your hand if you know, right? And so JavaScript, a lot, right? Python, much, right? C#, hopefully bunches. SQL, a few, right? It's just a very common scenario that developers don't invest that skill into interacting with the database, and instead they hand it off either to another developer, another senior developer, another team to do it, or entity framework to help with an ORM to help them abstract it away so they don't have to learn so much. However, I think just like interacting with AI and using Copilot to help you write your code, Of course, it is very useful, but there is more to it. If you don't know the fundamentals of the code, then you can get into a place where you're backed in a corner and you're like, why is this even happening? I don't understand. And you don't necessarily have all the tools in your toolbox to be able to diagnose and debug what's going on, right? So that's where we are with data driven. We want to understand the database, realize why it's there. We want to be familiar with SQL, even if we're not Jedi Knights at writing T-SQL at the same time. Okay, all that being said, let's move on. Let me say one more thing. My team is the developer experiences team, and the developer experiences team is writing all of the libraries and all of the tools because we're really like focusing now on developers from the database side because we've always focused on the DBA, and the DBA is that, I mean, you could just imagine the grumpy DBA that sits in the basement, slide pizza under the door, and that's just leave me alone. All right, that's not what we're talking about. We're over here now with the developers, and we want to be able to bring all the tooling to them and make it as easy as possible. So my goal is not to make you an expert in SQL. My goal instead is to make you aware of all the patterns that we want you to be able to understand and employ so that you can start using all the better pieces of each of the databases we have, not just SQL, although I would highly recommend SQL. All right. There is no doubt about it. If you have an app talking to a database, the thing you need to have in between the two is some sort of API. This abstraction layer makes it so that you can now talk to the database without worrying if your app knows how to talk to the database. This is now app to API communication is some sort of HTTP or JSON that you're talking through. And the API is then talking to the database through SQL. Now, yeah, how is it talking through SQL? You may be using Entity Framework here or some other tool. You may just be using plain old ADO.NET inside C#. That would be terrific. That's what millions of applications do. So nothing wrong with that. That is a terrific way to do it. By the way, I might just point out that we have a brand new SQL driver. You're probably already using it, not realizing it. We're upgrading it all the time. So there is a system.data.SQL server. That's the old driver. The new is Microsoft.data.SQL server. And in that, we have a lot of new capabilities. I'll kind of hint at those as we move forward. One of the ways that you can modernize your application is simply by upgrading the driver that you're using. So if you're at a certain point, if you switch between if you switch between system.data.SQL server over to Microsoft.data.SQL server, remember Microsoft is the new, then everything still works the same. It's completely interchangeable. And that's one easy way to do it. And there's a lot of capabilities that are built in, a lot of defaults that are built into it as well. So if you're not using that, then that's one way. Let's talk about things you can do to your app. The first thing you could do is to separate the client from the app. And that what I mean is we're going to build a client for the API. You're going to interact with the API inside a batch of code that is completely isolated from all the UI that's executing. So that means I can build my app and represent it here in the square, and it can do whatever, and it doesn't even know there is an API. All it knows is that there is a client. The reason we do this is the introduction of a seam, a place inside our application where we can start breaking it apart carefully, right? When those were together, and let me just go back. When those are together, we're like, all right, how am I going to break out the way we interact with the API so my UI can be upgraded from one thing to another? Maybe you have a WinForm application or a web application. You want WPF or WinUI. Maybe you want to move over to Maui, or you want them all, right? All of those need to happen. You can't do it because you've commingled all of the data together like that. So instead, we're going to break out the client, intentionally create a seam. Now, what actually could happen here is a complete developer effort where your team is engaged in refactoring the client and no features are added. No changes actually occur. The only thing is you're introducing this seam so that you can start, well, frankly, you can take your normal little square there and you make it super fancy into whatever application you want. And the client can just sit there and do the job it's supposed to do, and you don't worry about it. And so as your manager or whoever comes to you and says, all right, it's time, Jerry, let's introduce a few more applications. You can be like, all right, because I've got the client, I can introduce as many applications as you need, sharing the code to interact with the API, probably without any significant changes all the way around, right? That's a beautiful way to think about it. If you don't have those seams, then you don't have anywhere that you can attack to modernize your application. Now we can do this exact same thing on the API side. Now we have a repository. You may already be familiar with the repository pattern, And the repository pattern is really intended to isolate the logic that you interact with your database. So most repositories, this is where you would see all the data interaction, where you would have Dapper running, or you would have ADO.NET executing, or you would use Entity Framework and all the migrations. Whatever it is that you have, it makes sense to put them there. And the reason I'm showing them here is because now you may have a web API that is completely built on controllers. Nothing wrong with that. It is extremely fast, extremely powerful, an excellent way to build your API, but you have decided that you want to upgrade to minimal APIs, because minimal APIs certainly has capabilities that you do not have with controllers. When you look at the future of web APIs, it's definitely in the direction of minimal APIs. So you're like, all right, I'm looking at my API. Let's upgrade it. Shazam. Now, how does this work without a complete rewrite of all of the data interaction? It works easily because we've already separated them, creating this intentional seam. That is, we can think about this as an architectural pattern or a development approach, whatever it is that makes sense to you, so that the repository still sits there and the upgrade required to make it so that your API goes from one thing to another is actually very, very small, right? We've isolated all the code that needs to change. And so again, maybe you have some sort of handful of sprints that makes it so that your API and repository separation is accomplished in those sprints, but there's no feature change, there's no code change, right? I mean, there is code change, but there's no like operational behavioral change. So that's really nice, because now the API and the repository are separate. I've got my super API. I've already separated the client that talks to that API. So now I know the app is better. Now, here's something else. As I upgrade that API, I realized this one thing had to happen. I needed a new HTTP header support. I wanted to have caching enabled, right? So in-memory caching is now part of it. I wanted to change it so that I was reading from a JOT token, so I'm reading all of the claims that come into it. I'm wanting whatever it is, right? There's so many things you can do inside an API, and as you're doing this separation, you cannot resist this small upgrade, or maybe it's just a requirement. Every API now has to have it. Well, look how beautiful this is. Now I can make it so that the only code that I need to change is the API itself. The repository sits there, all the unit tests stay the same, the CI/CD pipeline never changes, right? That's really great. On the client side, the client itself is going to be updated, but all the apps, they don't have to be impacted. So now I have to pass this new HTTP header. Terrific. I will deploy the new client, the updated client, to all of my apps. It automatically is implemented for them, and it's the smallest amount of change because I've introduced all of these seams, making it so each of my components don't rely on one another in a coupled way. They just speak to each other, and they instead rely on the contract between them. So when the app is talking to the client provides a certain contract. When the client is talking to the API provides a certain contract. And the same thing when the API goes to the repository. Now, how do you talk to your database? Doesn't even matter at this point. Like what's important is the repository does it. And we'll talk more about that, because if you're closer to a green field than a brown field, boy, do I have a story for you. But all the way around, these seams are the beginning of modernization. Let me just back up and say this, and just kind of say it directly to you. If you do not have these seams, you are looking at modernization as a serious pain. I feel it for you, absolutely. Especially if you have merged all of these together, so that your app, the client, the API, and the repository all end up in the same project, or a little sort of cluster of projects that you have together with an interrelated sort of project relationships and dependencies that you can't get away from. And you're like, holy crap on a cracker. This is going to be a serious effort in order to do it. All right, let's keep going. Once you start thinking about your database and you're like, I want to make it so that my on-prem database is eventually going to be updated. So I'm using a cloud database. I know also that my client might reside in the cloud. I might move my API to a cloud. That's not what we're talking about here. You can do that so transparently that you don't even really need to plan for it. Instead, when we're thinking about the database, we can hide the differences between the different databases. So the one that's on-prem executes just about the same as the one that's in the cloud, depending on whether or not your enterprise has upgraded and has everything up to date, right? That's really the thing that pushes it back. So we're just about to hit SQL Server 2025, right? That's going to be released at the end of the year. That'll be the closest parity we have to Azure SQL DB. Azure SQL DB in the cloud, of course, it has every feature known to man. And so all of those features are slowly making their way into on-prem. And when we do that to this year is going to be the big push to have a majority of those features come down, including things like vector support, so that we can have AI data types that we interact with. All right. That being said, I just want you to see that the repository makes it easy. The app doesn't have to plan for a cloud-based database. The client doesn't have to plan for a cloud-based database. The API doesn't even have to plan for a cloud-based database. Instead, they're only the repository. See how we've isolated our code to make it easier than before. Now, earlier I was saying if you're closer to greenfield, but the truth of the matter is if you're ready and you're looking at your API and you're like, Jerry, this is mostly CRUD operations, CRUD, the create, read, update, and delete. This API in the repository seems very redundant to me. We have several projects, as a matter of fact. This drawing, we try and do our best with the seams. And I'm glad that you're pointing these out to me because it affirms what we're doing. Great. However, I have to say the API is redundant. It's copy and paste from project to project with the same work over and over again, introducing just this larger suite of unit tests that I have to have that I didn't have to have before. Here's another problem with the repository pattern itself. If I'm using ADO, if I'm using Dapper, if I'm using EF Core, if I'm using whatever it is, you know what they have to have? They have to have a driver. And now, the upside of the driver, which I was talking about before, that's really nice, is the new SQL driver includes things like retry policies, and it's very resilient and very redundant. Not redundant, but very resilient and very, well, redundant is completely the wrong word. You wouldn't have two. But it's the type of thing that you want, right? You don't want to have an older driver that doesn't have the same capabilities or is subject to older behavior patterns, doesn't have the same performance implications, and all the other things that you would want in it. However, at the same time, drivers kind of stink because what happens is the driver that you're using is out of date, right? Because it's been a year and a half since the project really ran. You need to upgrade the driver, but you're not 100% sure if the upgrade is going to wreck anything. So you leave it at the older one, even though you already read the article that said in the README of the next version of the driver, it fixes a security flaw that you don't want to feel that vulnerability. So now you're like, okay, I guess I need to update it. And here's the point I really want to make. Drivers are frustrating. And what if I told you there was a pattern that allowed you to remove drivers but still interact with the database completely safely and completely with the same set of functionality with no drivers whatsoever? So if you've ever written a JavaScript application that interacts with SQL, you know you've used Tedious, right? That's what it's called. And that version seems like it gets updated every week. You're always out of date. And the same thing with the Python driver, and on we go. Every time we interact with the database, SQL or not, we always have to have the driver, and that driver is always subject to being out of date because the team behind it is always doing their best to make sure it's up to date and secure. That's the upside and the downside simultaneously. So what if instead we took the API itself and said, let's just get rid of it. All of the code, just highlight it and hit delete. The purpose of this is to introduce instead Data API Builder, which says this part of your application, which is really just copy and paste from project to project. And it's just CRUD implementations of create, read, update, delete over and over again with every entity, every table, every POCO, and all the things. And you're like, man, I have done that before. And you're right, you've done it before, just as I have. And that type of code, because it's so mundane and because it's so repetitive and because it's so simplistic, is the most likely to have an error in it because you're bored with it. And so you get this sort of copy-paste inheritance as you go from one place to another, propagating errors that you might have in one and exploding your unit test code base so that you have all of this unnecessary code executing in your pipeline, right? It becomes more and more complex and more unnecessary. All right, so that's where Data API Builder. And so this is from Azure Data. We built it. It's open source. It's free. You could just include it as part of your application. It's container-based, so built for distributed applications. It is ready to go. And you speak to it from the client. You still would have a client, of course. It would be an API that you talk to over HTTP or JSON, the same. Nothing changes, and all the capabilities you want inside your API are still there. You still have caching. You still have claims-based authentication. You still have everything you want. Data API Builder already provides it. If you want a retry policy, it has the retry policy. You want open telemetry, it is completely open to like all the things that you want are completely in place. And so why not take all the code, just throw it away and replace it with Data API Builder? That's the reason we built it. That's the reason we're giving it to you. We don't care if it's .NET. We don't care if it's on-prem. We don't care if it's in AWS, to be honest. Wherever you want to run it is fine. It's completely free and ready for you. It supports SQL and Postgres, Cosmos, and MySQL as well. So we have a lot of options on the back end of Data API Builder to save you a lot of code and a lot of effort, and just it's a drop-in solution all the way around. The next thing that is a drop-in solution, and let me explain the problem. If I remove the repository, if I remove my entity framework, and I don't have my migrations anymore, and I don't have my POCO objects that represent the tables and their indexes and their keys and everything else, then as I am building out my application, where do I get that schema? Where do I get that data to make it so that my database is still in source control, still managed by my development team, still able to roll back to a specific point in time? I do that with SQL projects. So a SQL project, if you haven't seen it, it's only been around since I think 2011. So it's not your fault. It's only been there for a decade. It is spectacular, and it is the ability for you to be able to specify the DDL or those statements that represent the table. Like, here's my table, here are my columns, here are the types. All of that inside a project type called the SQL project. If you're not using that, well, then how are you managing your database? You've got to do it in one way or another. And if you're saying to yourself, well, I'm doing it all in Entity Framework, well, that's the reason we're talking about we need an alternative to Entity Framework, because if you have something outside of CRUD operations and you do have an Entity Framework, you may not be interacting with every table in your database. You still need a way to manage in a practical sense, in a reliable sense, and in a way that interacts with your CI/CD pipeline to automatically publish and create like deltas and updates, right? Just like migrations do in Entity Framework. All right, so that's what SQL project is, and I'll show you all this in just a second. The last thing is just to understand that the management from a developer point of view, that's you and me. We as developers, not DBAs, to interact with the database, we use Visual Studio Code, and we use the extension called MSSQL, Microsoft SQL. It's not brand new, but it is brand new in a way because the investment that we're putting into it is off the charts, and you're seeing all kinds of changes to it constantly. The reason that's happening is because we recognize that developers are using this tool more than any other tool to interact with their SQL database. So we want to make it the premium experience. We're also looking back at the tool called Azure Data Studio that's been deprecated. The functionality of that now is being pulled over into MSSQL as well. So you're seeing a lot of capability being introduced into MSSQL that gives you a lot of capability, just power, right? To be able to do anything that you want. At the same time, we also recognize that there are times when you don't have any access to the database, any ability to make a change. That's because it's run by another team, owned by a certain DBA, whatever it is. And so we make it so that Data API Builder can fake a lot of things, make it so that you can build things that act like stored procedures, but are actually just simple queries. You would never write the query. We don't want you to write the SQL anymore. We instead want you to interact with the endpoint and let all the SQL translation happen automatically by Data API Builder. So if you have the ability to interact with the database, you store your schema inside the SQL project and you deploy it through your CI/CD pipeline that way. If you then are, again, interacting and building out capability inside your database, writing stored procedures or whatever it is, that sort of operation where you want to have a real-time experience and have the full fidelity of what the database provides to you, you can use through the MSSQL extension of VS Code. That makes sense? All the orange pieces are part of the tooling that we've introduced to all the developers here to make sure that you have the ability to modernize your application in the fastest, smoothest, no friction way, right? That's the idea. I mean, look what you've done. Now you have the app and client that you're maintaining, the end. You don't have to worry about all this other code, and we've simplified the database really as best as we possibly can. We can't get past the fact that the database is the fastest, most secure way to store data. Of course it is. You don't put it in a file. You don't put it somewhere else. You put it inside a database, so we make that experience as easy as possible as well. All right, I hope all of this feels good. Let's then jump to Visual Studio so I can show you how you might see this yourself. So let me, there we go. All right, just like Jeff said, he used to work for a education organization. So I've created a classroom application. The classroom application, its job is just to allow you to take roll, right? To take attendance. So let me just go ahead and run it, and then I'll talk to you about it in just a second and all of its like smaller pieces. It's a WinForm application. I wanted to represent really the type of application you may be running anyway. This could have been a WPF, it could have been a WinUI, it could have been Maui, could have been web, right? I mean, of course, all of those are possible. They would all share a lot of code. That's the whole point. In this case, you would pick which class you're in. I'll go to my English class. Here are my 3 students, Daisy, Ethan, and Fiona. And I would be like, all right, here's whoever is here, and I click save, the end. There's a lot of capability here I would like to add that isn't there. But this is a demo, and I didn't want to spend more time explaining the demo than explaining the patterns and explaining the pieces around it to you. All right, so let me just back up and remember. I'm trying to make it so that I can modernize my application that uses a database. Does this application use a database? Absolutely, it does. Okay, so when I click save right here, or when I switch between classes, it is going and reading the database, or it's writing to the database. I've already gone the extra step because I'm a good developer, made sure that my engineering prowess was on display so that I go in and I look at and I make sure there's a service in between my client, my application, and my database. I want to make sure the service is there. So it is. This is what it looks like. Very simple. Let me back out. We're not going to do any UI work together today. I just want to talk about the backend data. So the next piece, I just want to show the structure and make sure that we're together. So there's only three parts to this. The first is I have my app. And so I didn't even rename the form. I just wanted you to see how silly and simple this is, right? So here's my form. I'll double click just to prove it's the same form, but it's just, it's just a grid and a button. And then inside this application, while the designer loads there, right? So it's nice and simple. Yeah, those were the days when UI could be that simple. Right now, it's like everything's got to be dynamic and different themes you support, and on it goes. Okay, that's my app. Nice and simple. Here is my API. My API. Now I went ahead and I made this a minimal API, right? So I don't need to show you the migration from a controller-based API to a minimal API. That is just something you'll be able to do on your own. I want to talk instead about what this means to a database application. So I have just a handful of things where I get a list of all the students, I get a list of all the classes, and then I get all the attendance information. And then down below, I can post that, or I can update all of those values back into the database. It's not super fancy, right? I mean, don't look at the code and think I could really learn a lot from Jerry's coding here, because this is about as simple as you can get. And it's really just intended to let the data flow to you, let the data flow back, right? That's all. And so let me close this. So I have two applications now, or I have two projects in my solution. I have the API and I have the app. What I'm not showing you is the database. The database is not part of this. The database instead is something I've been building on the side. And this is a very typical scenario for a lot of engineering teams, where instead of having a regimented process, where they put rigor into the structure of both the schema and the way it's stored in source control, they kind of do all their table management directly into the database. And when it comes time to go from one database to another, they point to their developer database, they do a schema compare, they write an update script, and then they run that in production. Does it work? I've done it for years. It absolutely works. Is it the best practice? No, that doesn't mean it doesn't work. I don't want you to hear that all of these things are me trying to fix something that doesn't work. It's just making it so that it's better down the line. I just want to remind us that the developer coming after us is an axe murderer, and he's really in a bad mood. And so we want to provide to him instead a solution that makes the most sense and is the easiest to debug and is the easiest to update and modernize. So that's where we're going to go from here. So very simple. I will point out, I do have this little Poco project. Has a couple of classes. These are the things I needed to pass back and forth. Do I have the name Poco in the name of the model? Yes, I do. Is that the dumbest thing you've ever seen? Yes, I'm not proud of it. Okay, but anyway, there it is. It's really nice. I would rename them. They're in a Poco namespace already. You shouldn't have to do that, Jerry. I know. OCD's kicking in all of a sudden. That's the only thing inside this project, by the way, are those three classes. So it's shared by both the API and the app. That allows the API to pass the class. It also allows then the app to receive the class, right? So you can serialize and deserialize into the same objects and know that everything's going to be okay, right? That's the important part. However, I want to go into the first step of modernization. I want to make it so that I can clean this up as best I can. Now, it turns out inside this app, let me close the form here. Somebody has already gone through the work. Somebody, I guess it was me. Somebody has gone through the work and they've identified that there is an iClassroom client. All right, so let me back up a couple of slides here. And let me back up to right about, well, this is fine. Well, we don't have to have two databases, but this is what we're building, right? So we want the app and we also want the client. And so here we are. I have the app going on here and I now have the client inside my app. So somebody's really done some good work here, abstracting away the logic. So at least it's not in the form, right? It's not in the code behind of your XAML page or somewhere like that, right? At least we've done that. That's the starting point. And so I can see everything is in the client folder. Now, this isn't what I want to do. This is not representing this diagram, but it is on the road to that diagram. Instead, what I want to do is make it so that this folder is now outside as its own project, right? And still able to run. So now let's go into my Modernized folder where I've got all kinds of pre-baked things that are going to be fun for us to have later. So let me open up and bring the client down. I'll move it out of that folder so we have it here. So I have the app, and now I have the app client. All right, so let's so we know the app client is going to have, spoiler alert, the exact same logic that's in the client folder. In fact, if you look really close, these aren't normal icons. These are actually shortcut icons because I have added the files by link only inside Visual Studio. It's a cool feature that allows me to have a file in one place in my solution, but show up in multiple. So I'm going to go ahead and unload or reload, sorry, reload. And so now you can see here are the 3 files, including the interface, the 2 clients, and the models that exist here. All right, so the models are actually meant to make it so that I can hand to the UI something that doesn't expose or leak out any of the architecture from behind, right? So let me just explain that one quick time. I have all of the models shared between the client and the API. Those models actually are shared between the repository and the client. They just happen to pass through the API. The models are those POCO objects, POCO, the plain old CLR object, which usually are just classes with properties only. They're just intended to represent the objects that are going to be passed one place or another, right? They typically represent the tables, or at least the views or partial tables that are in the database. As they go into the client and then pass to the app, I don't want to do that anymore. I want to translate those into something the app cares about. The app doesn't care how the client is talking to the repository. It certainly doesn't care how the data is structured inside the database. So instead, I have this new set of models. So I have the first set of models really because the repository and client communicate that way and they pass through the API. I have the second set of models, not the POCO objects, but the ones intended for the client. Right here at the app side, this is the app is thinking about the UI. It doesn't care about the database. So it doesn't need everything spread out and third normal form. It wants everything nice, collapsed, and intended to make the UI easy and nice and efficient. That's the reason I have another set of models here, and you can see they do not say POCO at the end. They say model. They're intended for the UI. Just know that everything inside this folder and everything inside this project are exactly the same. So that means I should be able to delete this client folder, which I'll go ahead and do now. I actually just did, but it didn't delete for me. Let me see. Well, maybe I could delete the file. What's happening? Am I still running? Oh, I am still running. That's funny. Okay. I just stopped running. Beautiful. My demo that I was running from the beginning here. Now I can highlight this and hit delete. It's asking if, are you sure? Are you positive? Absolutely. Because what I want to happen is this, the perfect separation of app and client into 2 projects without having that code over each other. The dependency inside the app now needs to include the app client. So I'll just drag it up here so we can add it. Now the client is part of the app. I have built exactly what I wanted to do. Sometimes, this is why I was saying you can have a handful of sprints with your development team accomplish this without very much code actually changing. All you need to do is introduce projects and understand the relationships between them. So now, hopefully, I can say Control-Shift-Build or Control-Shift-B for build. Everything builds and everything works because it doesn't know any different because of the project relationship, it just brings it in as if it was local as it was before. Okay, that's step number 1. That's your first modernization step, which really enables your application to have the seams it needs to be upgraded. Let's do the same thing for the API. So now let me close this. All right, open up our API, and we have this repository all set up, right? And all of our migrations are just sitting there looking at us. And so we have the context that we have. The context itself, of course, is internal, right? I don't expose my DB context externally. Of course, right now I'm inside the API. There is no concept of external yet, but it will come soon. And then instead, I have this like generic repository that does the basic things that I need to do for the data. All right, so this is the repository on top of the context. A lot of developers just use the context, never use the repository. Is that the wrong thing to do? No, it's not. It's not the wrong thing. It can make your code more complex than it needs to be and make it so that some of the logic that you do is redundant and repeated over many places, but it's not necessarily wrong. All right, so just like before, inside our modernization floor, I just happen to have the repository project. All right, so this project represents all of the logic that is in the repository folder, right? So these 3, it has or 2 really, the context and the repository. Those are the two things that know how to interact with SQL Server for me. So whenever I need to save a file, whenever or save a value, whenever I need to read a value, the repository and the context take care of everything. It is all there. If I have one developer on my team who's specifically good at interacting with the database, I stick them on these two files and make sure everything is perfect. But the truth of the matter is, EF Core makes it so it's pretty easy to get this right and pretty hard to get it wrong, right? And so that's nice. It does mean that there are certain things you're not able to do. It seems like a weird thing to say, but EF Core can only do so much. You can still point, I suppose, at store procedures to accomplish a lot of the things you might want to do. But all that being said, what I want to do next is highlight that folder and get rid of it, making it so that there is no repository in. I'll do it this way. Wonder what was. It's not like Visual Studio to hold on to something. And not one file at a time works great. Okay, so look at my API. Now look how clean it is. Now I know this is a simple demo, and I hate it when demos are overly simplified. But I will just point out the reason it looks so clean is because the logic of interacting with the database is now gone. Now it's just the API, and the logic of the API is sitting there looking at me. If I load this or reload this, I can see all the files that were there are still here, right? I still have them, but now they're isolated into a project. I can drag this up now as a dependency, and when I look at the dependencies in my API, it now has a dependency inside my repository, which is what I'd want. If I open that up, I can see its entity framework. All right, terrific. Now I have my API and my repository separated. I have my app and my client separated. That's what I want to do because this is the dream. And by the way, we just landed on the dream. This is unbelievable. All right, so this makes me very happy. So if I hit F5 now, this is quite the excitement that I can delete all of these files and add all these projects to my solution and then hit F5 again. But I can because it's a straightforward thing and I've kept it really simple for the sake of this demo, right? So here I am. If I open this up, I can see all the classes. I can go to English and you can see that it's reading the data, right? Because it's not all blank. And so that's pretty cool. All right, now how much real change have you done? And I just want to circle back to one of the most important things is the preparation for modernization. If your application was written over time, little things were added, features were added, and you just see this like this thing being built, and it's just this giant blob. There's nothing wrong with that. That's the way business is, right? I mean, that you're in business to make money, and you're making money. Terrific. But when we think about the inevitable future of modernization and the reason you modernize, and one of the reasons we modernize to, let's just start with the next version of .NET is pure performance, right? I just actually rewatched a session from a few years ago. The chasm, the performance chasm, that's the awesome word, between .NET Framework and .NET Core, right? It's absolutely unbelievable the difference between the two. And you're like, why should I do it? It looks like they're exactly the same. They are not the same, right? It is crazy. And the using .NET Core, there are many benefits in the language, certainly. Now that we're up to C#12 and we have a lot of new capabilities we haven't had before, those beautiful developer features that are really productivity enhancements are really only available as you go into the core direction, but also the overall size of your app and your ability to target multi-platform and performance and scale and security and features and blah, blah, blah. That's all this day has been about. So I don't want to say all the things that everybody else is saying, but it is true. And in order to do that, you need to have a plan, and your plan probably is the preparation for modernization, the preparation of making it so that your app now has seams. We've now made at least 4 places that we can update and make changes to without making a cascading set of changes to all of them, including the database, by the way. I can make significant changes to the database and the repository because I'm using the repository pattern and not interacting with the DB context directly. I can hide a lot of the changes and updates that happen to the database too. It's really, really nice. I'm not really talking about upgrading to a new type of database. Back in the provider pattern days, we used to be obsessed with this idea. You know, what if I went from SQL to Oracle and then back again? You're like, oh, slow down. Nobody does that. Like, that's ridiculous, right? If out of 5,000 applications, one did, right? And you're like, okay, but now we've spent countless, developer hours building the provider pattern into our application. So we're not talking about that, but we are talking about an abstraction layer into a repository, making so the interactions with your database are hidden, right? So you don't have a bunch of, oh, be sure and get this data and that data and join it in this way in the API. The API should know how to do that. That's why we add the repository. All right, back to it. Now we have 5 projects inside our solution. Okay. Now, the reason this is good is because the more you have things separated, the closer we get to the separation of concerns. The more we have it so that we can isolate the skills of each of the people inside your team to be able to focus on each of the projects. Listen, I'm always on the API. I know everything about the API. Jerry is the teammate that is always responsible for that project and that small piece. Sometimes you just accidentally leave teams on. And maybe you are the one who understands the UI. You know XAML, you know the web, you know whatever it is. So you're the one responsible. And because we've isolated everything into individual components here, and now just imagine I might have several APIs with several repositories and different databases are the same ones. So don't think that it has to be this simple. I'm just talking about separating and isolating so that you can have this separation of concerns and also the separation of responsibilities, not just for the developer, but for the code itself. And let me just back up again and say what I mean, that this client here does not know how to talk to the database. That's because the responsibility and or concern of being able to talk to the database is isolated in the repository. Right? So it's really nice, right? This is really, we're talking about concepts more than anything else, boxes and stuff in PowerPoint. Okay, so I have all 5 of these as well as the POCO models that are shared across the repository and the client, and then they pass through the API. All right, what's the next thing I could potentially do? Well, the next thing that I would most likely do is, by the way, can you believe that even worked? That's incredible. All those changes and then hit F. That's incredible. All right, so the next thing I'm going to do is bring out my database. Okay, so this is a plan, by the way, right? So I know that I want to move into a distributed architecture using containers and using Aspire if you want to do that. I'm going to show you how to do that here in just a second. And I'm going to start by saying I want this project here, the classroom.sql. This is a SQL project, SQL right? So when I was moving forward, right here. All right, this is the SQL project. It's a special project designed. If you look at it, it's still an SDK type project that allows you to point. Let me click on it. Sorry, it is still an SDK type project that allows you to point to. Every time I click it, I can't show it to you. Hang on. We're gonna have to select edit. You know what's hard to find? The one that says set as startup project. I can't tell you how many hours of my life have gone up and down looking for just that one. But it's a regular SDK project that allows you to add just regular files and give them the .sql extension at the end. Those .sql extensions, you can see I put them in a table folder, that's all. But they do represent tables. I just wanted them isolated, or I just wanted them organized for myself. I could go into like classes, for example, and if I hide this, which is just a helper, this is the class, right? It's just defining what, that's the table SQL. It's just defining what I want it to be. Now you're thinking to yourself, I don't really know how to write SQL. That's totally okay. You can, let me close it and open it up so the designer pops back up. All you have to do is do up here, like, oh, I wish I really had this other field that could store a date. That would be nice. Or now we have it, right? And so it's written all the SQL for you. So it's nice to give you that. And what happens is when I right click this, I have the option to publish. Publish is different than build, and publish is different than publish when we're looking at a web application. If I select publish here, let me see if I can go ahead and do that. If I select publish, it'll pop up a little dialog that asks me, where do you want to publish it to? So unlike a web application, this is a database application publishing to a database. It reads the schema of the target database. It combines and builds the schema inside your entire application of all the tables and stored procedures and views and triggers and whatever it is you've got. There's nothing SQL can do that we can't put here. And so it reads all of that, compares it to the one that target, builds automatically and dynamically for you the update script, a little bit like we were talking about before. Remember when we talked about comparing the schemas of your development database and your production database, building an update script between them and then executing that for your migration. Now I can do that one step at a time. One new field, no problem. 2 new fields, it'll build all of that automatically and is completely command line driven, so I can put it inside my CI/CD pipeline, pushing this out to my UAT developer or my UAT database. And every developer then can also have their own database as well. One cool thing I just want to show you while I have it open is it also supports scripts. So this is how I seed the data. This is a lot different than the seeding data inside EF migrations, isn't it? I mean, you can just write it the way you want it to be, and everything is just where it is. You can add the logic on whether or not it's run, and you don't have to worry if the environment variables are set correctly or not. Right? That's super nice. Also, I don't have this stack of of migrations either, where they are cascading and building on top of each other, which, by the way, fully functional, absolutely works. Not talking about it like I don't like it, right? Talking about it instead, because I know we're going to a world, we're pushing towards this simplicity where we may not even have a repository. You may have a repository. You may still have migrations. I don't know. It's going to be up to you. So where migrations are considered to be called code first, this is data first, right? Database first sometimes. And so now I can right click this. I can publish it and my database is ready to go. I can also make this when I get to the Aspire world, I can make this so this is what gets pushed into my SQL container, which is really nice. All right, right on track. I'm feeling great about this. All right, so now that I have my SQL here, I can start thinking about what would it look like to get rid of my repository. All right, so let me open up. Let's see. I'm going to let's see. Can I open this in a folder? Let me just copy the full path and say code. I'll open up Visual Studio Code real quick, where I will open up a folder. Wow, it's way over to the side here. Let me just pull it right there. Very nice. I'll say open folder. You guys have done this yourself. I'll change the font size here in just a second. Right, so I want to open up the classroom completely. There we are. Bigger, bigger, bigger. All right. Now that I'm just sitting here, I just want to talk about now Data API Builder. This, I'm going to go back here a second. This circle in the middle, right? Well, how do we get that started and what does it look like? Well, it's a .NET tool, so it's cross-platform. You can install it yourself, Microsoft.Data API Builder. And it also has a series of, it also has the ability for you to, interact and build it all out inside Visual Studio Code with an extension that we have, which is what we have. While I am getting ready here, let me just think real fast. I'm going to grab, I have a connection string, right? Oh, I'm going to get the connection string. All right, you guys can write this down. I have it inside my app host. So let me right here. I'm going to go to user string. Go to secrets and just grab it real quick so I can show you this demo. We'll come back to that. By the way, good luck. All right, so I'm going to, inside this folder, oh, there's my daughter. I'm going to right click and I'm going to say dab init. All right, so when I say dab init, this is creating a data API builder. It initializes the one and only file it needs, right? So I am going to create that file. Here's the connection string. The only change I'm going to make is this right here. It needs to be local host. That's because I've got SQL running here locally in a database called Classroom, and I've got the most complex set of credentials you can ever imagine. I'll go ahead and just hit enter there and let the application do the rest. It creates this file for me. And in this file, I'm just going to click it and show you, it has all the ability to expose my REST endpoints. By the way, this is more than just a REST endpoint, where you might say .map get, and you can have a minimal API. This is .map get on freaking steroids. It gives you the ability to filter all of the data inside it so you can add where clauses. It gives you ability to project or have a select statement so you only bring back the columns that you want. You can do order by, pagination is built in, and caching is built. I mean, all the things that you want. So I don't think that this is just a replacement of minimal API. Instead, this is a replacement of all the things, right? So it's really great. But what I want to show you is down here. I should tell you this while I can. It's not just REST. It's also GraphQL. If you've ever used GraphQL, Data API Builder gives you that too. You don't pick between them. You can see in this case, both REST and GraphQL are enabled, and it's pretty awesome. These are all the tables that I've exposed, store procedures or views. So if I right click and I say, let's add a table, right? I can say, let's have attendance, classes, and students. I don't want my entity framework migrations, that's for sure. All right, so I'll take all three tables that are in my database. And when I say go, I can see they just been added automatically to this file. Remember, this is the one thing you need. This isn't code generation. It's not a library. It doesn't require, it sits in a container and you hand it a file. And that file has what tables and what the connection string is. So now if I right click this again, and I could say something even cooler, I could say, let's build some relationships, right? So now all of the tables are relating to each other one way or another because we have constraints already built into the database. So I can say, let's go with that. Shazam. Now, if I right click and I say, let's just see what this looks like, I can visualize it, builds a markdown, adds a mermaid diagram for me. And it shows me, oh yeah, there are the three tables and this is how they all relate. Isn't that cool? And so I'm like, all right, now I'm starting to understand this is my API and what the expectation is that I'm going to go through. So if I right click this one more time, I can say validate. Validate makes sure it can talk to the database and everything is set up correctly. I didn't have to validate. But now I can say start, and now it doesn't require Docker, not yet. Instead, it's just running it here locally so I can interact with it in a simple way. So you can see here it is, localhost 5000. I'll go ahead and click that. I've got it running down in another browser here. There you go. It pulls up and says everything is healthy. I'll say, is everything healthy? API/CLASS. Yes. All right. So there's all the classes, all 3 of them, right? Now I'd like to be able to say complex things. I have Swagger built in, right? So that's part of Data API Builder. I didn't have to do anything. I can disable it as soon as I change its mode from development to production. And if I go into GRAPHQL, I can go to GraphQL. I can see that this is Nitro, or the client that allows me to interact with all of the endpoints. So let me add a brand new query. This is a graph query. If you've never seen one, it's just kind of a cool thing, right? So I can say, give me a list of all the classes. Boom, there's a list of all the classes. And because they have relationships, I can do a really cool thing here. I can say, show me, let's see, all the students by name in this class, right? And so boom, now I go, and I can see that in the math class, I have Alice, Bob, and Charlie. Now think about this. I've already given you the REST API that you need, and so you can get all the data you want at one endpoint at a time. GraphQL goes to a single endpoint /GraphQL. You create a query like this, and you get the entire block of data structured in the way that makes sense for the UI you're building, right? So a lot of capability. You want REST, you want GraphQL, you want them both, whatever you want, it's kind of built in and you're ready to go. Okay, now that I've got it running, I could point my Data API build, I could point my client then to use that instead. Let me show you what I mean by that. I'm going to close Visual Studio. I'm going to pull on close Visual Studio Code here and get back into Visual Studio. And say now, so that's one way, right? So now I could have Data API Builder running because I did it from the command line and everything's good to go. I can make it part of my build script as well, right? So it's no big deal. However, I'll pull this out of Modernized. What if I had an app host and I were to make this app host where's this? Set as startup project. Like I said, it's the one that gets me every time. All right, so now that I have that, all right, now Data API Builder can be part of my solution because it's a distributed solution, right? So let's do that. So let's get my secrets out. That's embarrassing, having your secrets on screen the whole time. And look at program inside app host. So you've already seen this before, and I have a more complex one down here. I'm going to hide it just for now, just so I can talk about the basics. So I could say first things first. I'm not going to add in the normal way of adding a SQL server, where I say builder.add SQL server, because I already have a SQL server running, and this is the scenario for a lot of companies, right? Where developers already have a dedicated SQL server running on their machine, running in a shared location. They're not really interested in the container side of that part. Fine. If you are, that's the reason I had this code down here. You could just say var SQL server builder add SQL server, right? You could do that as well, but in my case, I'm just saying, let's just add this connection string only. This goes into the secrets of this project, which I have already shown you, and it pulls back the connection string called SQL server. All right, so that's nice, puts it in a variable right here. But look at this beautiful thing. I can also say builder.add Data API Builder, and now I have Data API Builder as a component inside my distributed application ready to go. It is on API port 1234, and this is the file, that same file I was manipulating before. I have already manipulated and provided here. What's special about it, and it's sitting right here, right there, is it reads from the connection string reads from an environment variable that's being passed to me by Aspire, right? So you can see it's connection strings _ at SQL Server. Where's that come from? Well, it comes from, whoops, clicked off of it. It comes from right here. It is a connection string. That's where the connection string prefix _ so that it's Linux compliant. And then it has SQL Server. So if I called this Jerry SQL Server, I just changed the environment variable. So now it's connection string _ Jerry SQL Server. All right, so that's good. I could push that then into Data API Builder, which can then read from the variable. And when I publish this or I deploy this somewhere else, then the environment variable inside my container could be controlled by Key Vault or whatever it is that you guys do, right? And so here's my application being added just like a normal project with a reference to Data API Builder, not to my database, because it has no reason to have the database. And finally, I'm going to wait for the database, making sure that it has, I'm going to wait for the API, making sure that the API is fully deployed. So it does take a second. I mean, just a second. You saw how quickly it started, but it does take a second, and you would hate for that race condition to occur and make it so your project blows up when it doesn't need to. The end. This is the exact same thing, only making it so everything is running inside a container instead. So if I hit F5 now, Lord have mercy, let's hope this works. I'm right at the end. This is the grand finale. If there's any bug whatsoever, no, it's gonna be great. Okay, let's see. Anytime now the dashboard will pop up. That's the one. I'll bet it'll pop up on the wrong browser, as it did. I'll bring it over. Okay, so what I want you to see, I didn't point it out fast enough. So there was that momentary delay when the API was running and this was waiting for it, right? And so now that everything is done, I can click on localhost 123, which you know is forwarded then through Docker for me. I can say /API/classes. Now this is pulling from the same database, yes, but it's pulling from a different API running inside of, and I have Docker running as well. I'll just fill the screen full of applications. So you can see here's the data API container that's running on my machine managed by Aspire for me, right? So everything is nice and componentized. If I go back to my resources, I can see that here's my application. Yes, you can have a WinForms app or a console app, right? You can have anything running. And the same console out that we saw before is still sitting there nicely. And all of the relationships between them, nice and simple because it doesn't see that there's a database because I didn't put that inside a container, right? Isn't that nice? Or sorry, now does it still work? Yeah, you can see I've already pulled back the list of classes and there's all the information. Now, instead of running it, so I have a command line executing and I have the dream world. I'm right here, not right here where I'm using Azure SQL DB necessarily, but I could. But instead, I've got it where I have eliminated an entire chunk of code. So if I were to go back into my Visual Studio here, these two projects now could be completely deleted. That would have been terrible. But these two can. And the reason they can is because the client has both the API, the original client, to be able to access what we wanted. And I wrote the identical signature, right? Because I'm using the same interface, but one for data API builder that brings back the same information. That's nice. So now it switches dynamically because of dependency injection. So that dependency injection, let me just show you, looks like this. It's kind of dumb how easy it is, but it looks like right here. If data API builder has its environment variable injected from Aspire, then I know that it exists as a container. And if that's happening, then I'm going to use data API builder instead of the regular API. And I just switch between one singleton or another. They both use the same client. So that's the beginning, right? So I can have it almost like A/B testing going through where I can have a little bit using this client, a little bit using this client until I completely delete one of the API endpoints that I want because they work the same in the end, right? Let me go ahead and stop it. Last things I want to show you are just a handful of pieces in the slide deck here. And so one thing, and I'm going to go really fast, but I want to make just the point that data API builder, it points to a single database, but it can point to multiple databases from the same data API builder, which means you can start to bring together hybrid queries inside a single payload. That thing that I showed you in GraphQL, that can work across multiple databases, bringing back multiple databases in one payload, even if those databases are NoSQL databases. I could point to Azure, but I could point to SQL, but I could also point to Cosmos DB, and they come back in a single payload. If I'm thinking I want this all to be microservices, that's where Data API Builder really shines, because now you don't have to build any of the API part of your microservices. You just start exposing each of those. And remember, it's deployed as a teeny tiny container that you can control the size of. If you want the third one at the bottom to be super big, you just make it big. Otherwise, it's as small as you want it to be. So that part's really nice. And if you find that it needs to really be able to focus, you could do that too by having multiple in one place, right? So you can scale both vertical and horizontally. And if it turns out that you have just one database, but you want to have tons of different types of endpoints, each one with a different configuration, but all pointing to the same database, accessing different tables, you could do that too, right? I mean, it's just whatever topology matches, whatever the kind of business you have, including the nice, clean, simple way of doing it as well. Let me give you some takeaways and resources that'll be valuable to you. So if you've never heard of Data API Builder, you can go to akms/dab or /dab docs. It'll take you right to MS Learn where the docs are. So remember, it's completely license free. It's open source. You can check out the code yourself, steal it, use it on-prem, use it in any cloud you want to. It doesn't matter, right? It's really nice. Supports all, Microsoft SQL, Cosmos, Postgres, and MySQL. If you've never heard of SQL projects, well, here you go, akms/SQL projects. You can learn everything you want. It's built in both the Visual Studio and Visual Studio Code, completely supported in GitHub Actions and Azure DevOps as well, right? So really, really great. If you didn't know already that you can get free SQL Server, you can. Right there in Azure, you can go and get, it's 32 gigs of storage, 1,000 core. You can get actually 10 of these per subscription forever. There is no like blow up clock or anything like that. You just go get it. It's pretty freaking awesome. Yeah, it's really nice. So if you're wanting to dabble with it, here's the way to dabble with it. It's pretty great. Okay, last thing I want to say is if some of the features that you feel like SQL and all of the things in Azure data you feel like they're getting away from you and you haven't learned all the new capabilities, we've isolated them all down and put them in one place so that you have a learning path that allow you to learn all the new modern capabilities that we've added to Azure SQL that are also coming now into SQL 2025, and an applied skill you can take that will give you a Microsoft credential that you can show on LinkedIn or however it is you show that you're smart to people. Right? So a lot of neat things there, AKMS/SQL/dev/path. All right.